All right, so let's begin for today. Yeah, so I wanted to, let's see here. Yep. Let me start looking at the calendar. Okay. So, yeah, we'll have, let's do some announcements. I think that's good. So today and Wednesday, we are going to be talking about functions. And then next week, and Wednesday, the lecture is at 1 p.m. for various reasons. I have something else to do at 4, so I have to excuse myself from that lecture, at least at 4 p.m. So I'll just do the live stream at 1 p.m. again. So sorry about that. And then, so I'll go over a bit of the exam format for next week, either today or Wednesday. And so you get an idea of how at least last semester's exams went and stuff like that. So, and then what else is there to say? I think that no, I think that's really it. So yeah, the exam format we'll talk about, Wednesday's lecture, and then today and Wednesday are functions. So in terms of the exam format, basically it's like a homework. I'll assign 5 problems to complete. And so that's how the structure of the exam will be. There will be a multiple choice section, probably on Blackboard, to complete. Generally, my expectation is that it takes around 30 minutes to do the multiple choice. I will give you 2 hours to do it. Yeah, and so basically it's just like a homework. Basically, I think I may not. So what it's going to cover is everything up to this week, probably today. So basics of functions. Nothing too complex with functions. So no recursion, none. If you think like, man, that's a really complicated topic about functions, it's probably not included in the exam. Basically, the things that are going to be included in the exam are going to be like functions, arguments, returns, local versus global. And so we'll talk about those things today. I think that's basically all the announcements I have. Yeah, so the exam will come out, if I'm nice, maybe Friday, but probably, I guess I'll say it'll come out Monday, and you'll have until Friday midnight to complete it. But I mean, I might release it early, so, but if I don't, then it should come out on Monday. You have until Friday to complete it, and that's it. The multiple choice section will be up on Blackboard. The coding section will be released in a Google document. So it's basically 2 parts, coding and then multiple choice. And that's really it. Okay. Definitely not today. No way I give you 1 to 3 hours warning. Definitely next week. Plus, you have homework 4 to do right now. So, not the exam, right? Yeah, so it's on the schedule. It's on the calendar that I've released. If you notice, it's next week. And I think the reason why I chose... It makes sense, right? Because the first midterm is due next week, and then spring break happens. And that's good because it'll be due the same time as the problems. So, yeah. Definitely not. So notice here, the first midterm week is next week, and then the midterm is due. And then I think we have spring break according to this calendar. And then I assign homework 5. So I might write homework 5 and release it sometime during spring break. But this will be the official assignment date for homework 5. And I'm not going to ask you to do any work over spring break. So I think that's probably why I picked to put the first midterm here, because it kind of makes sense in a way. And then we'll continue on. Actually, we'll have lectures that are not about the exam. So this material, file I/O and dictionaries, will be past the exam material. But that's good because, you know. Anyway, okay. So yeah, the only downside is that I think there's one period where you'll have a project and a midterm that go at the same time, but it'll be the first week of a project when you'll have to do the second midterm. I guess technically I could always move everything back a week and just make you do homework 5 over that, and then we could have less, so we wouldn't have any overlap of any assignments. Anyway, okay, so that's what's going on in the course from here until after spring break, basically. Okay, so let's begin on functions. So functions, what is a function? Basically, a function is a block of code. At least this is kind of our informal definition, which can be called and will run anytime, or I guess, and will run and then return back to the place where it was called. So basically, the idea of a function is that you have a little block of code, some block of code here, and then here you call my function, like this. And what happens is, here's your block of code, and then here's the my function block of code. And the problem is you don't necessarily know exactly where my function is. My function could sit in a separate file. It could just be in your file. It could be your function. It could be some other function. You know, we don't know. But anyway, so what'll happen is you call the function, so it'll jump to whoops. It'll jump to here. And then what'll happen is it'll run down through the function. So it'll run down. Well, let's not have it do that. It'll run through the function all the way to the end. And then what it does is it returns back to essentially the line where it was called, like that. So that's basically the order things run in. So it's different than a loop, because with a loop, what happens is you don't actually leave your code block. You just run something in the same block, right? You just have a little sub-block. So loops create sub-blocks of code. Functions allow you to jump to a specific point, run some code, and then jump back. And so the thing is that functions are excessively useful, because what they do is they allow you to basically modularize your code. And what I mean by modularize is they allow you to develop functionality that can basically run separately from the rest of the code. And if it gets run multiple times, then you save on, code space. Basically, you save on space. And also what it allows you to do is it allows you to test the functionality of your function individually without requiring the test of your whole code, the whole project, homework, whatever, to be tested. Now, for homeworks, you're generally going to have one function to write. So testing your function is testing your homework. But in terms of projects, testing a single function is going to be testing 1 out of 10 parts of the homework. So that's kind of the idea about functions, is that they give you some degree of modularity where you have code that's separated away, which is good because the thing is that the more separate your code is, and if some code can't affect other code, then you know where the problems are when you start debugging, right? It's easier to track where the problems are and I know that I haven't been explicit about exactly how functions prevent code from affecting other code, but let me show you. Let's begin. So this is like the theory of functions, and there's not a whole lot to it, but if you remember, this is the last piece of our puzzle, right? So there was a sequential program flow, so there's control flow, and so there's sequential, which means one line after another. This happens in, say, print statements, input statements, variable assignments, etc. Lots of statements have this kind of thing. Then there's conditional. A block is executed only if a condition is true or maybe false, right, in the case of an else. Then you have iterative, which is basically loops, right? So conditional is if statements, if else. Iterative is all kinds of loops, right? A block of code is executed multiple times based on some rule. The rule is either a for loop, where it's cycling through something, or it's a condition. So you could say that while loops are kind of a bridge between conditional and iterative, but really we would probably call while loops more iterative than conditional, because the condition only checks whether or not the loop will run. And then finally we have functional, which is the notion that blocks of code can be called independently and run, then return their results back to the place from which they were called. So this is basically the like four the 4 bits of control flow. And after this, we don't really have any more control flow to talk about, because everything is either sequential, conditional, iterative, or functional. There's really no other, maybe some other languages have some different kind of control flow, but in Python, C++, C, Java, JavaScript, I think Ruby, just all kinds of languages, this is basically it. There's really only these 4 things, and the reason why is because, and this is basically all of programming here, right? So programming is either you're writing some lines of code, you're writing some if statements, you're writing some loops, or you're writing a function. So I think I've spent long enough talking about all the theory and not actually getting to any substance, so let's get to some substance. So let's define a function. So how do we define a function? And the answer is you use the keyword def. and you would call, so this is my function. So you have to give it a name. So you use def, and then, you know, the name of your function, and then an open paren, right? And then a closed paren. And so that's it. And then after that, colon required. So basically that is the way to declare a function. And then after that, everything under the function must be tabbed in, just like if, for, while, etc. Like elif, else, right? Just like all those keywords, you have to tab your stuff in. And so in this case, you also have to tab your stuff in. Functions should be declared outside of the if name statement. Just to, there's a few reasons for that, but please do that. Okay, so what do you do inside of a function? Well, you know, I don't know. Let's do a simple example. We can print, hello there, I am a function. And then we can say input, you know, how many eggs do you need in your omelet, right? Function variable, oh yeah, so the naming conventions for functions, yes, use snake case. So that means lowercase separated by underscores. And how do you spell omelet? Because okay, 2 T's. There we go. Interesting. Okay. Okay, so here's a function, right? And now you might say something like int input, something like this, and then you might say print, you said eggs, right? So, will you ever use camel case? Not in this class. So Python doesn't, well, I mean, Python is a language that also comes with a coding standard. So Python's coding standard says don't use camel case for whatever reason. They just don't like it, but yeah. Okay, so let's run my function, right? So this is how you call a function, right? This is the function call. So this would be like the function definition. And then everything inside of here is the function body. And I guess I haven't talked about apparently there are 2 spellings for it. Yeah. Anyway, so let's see here. Let's run it. How many eggs do you want to make your omelet? 17, right? And so let's do this multiple times just to prove that we can actually do this. How many eggs do you need in your omelet? Say 5. And then, right, so now so that was the first function call, right? And then it completes, and then it'll go to the second function call. So maybe I'll even add some print statements. Right, second, third, I don't know, I'm putting spaces after it, 4th, and 5th, right? That way we can see what's happening. So let's say 5, and then here you see that before we went into the second function, you know, we said something like how many eggs? No, 17 again, or 187 because I can't type. Okay, then 187, 224, and 1024, right? So at this point, what we've learned is that the function can be called multiple times, right? And it starts over at the beginning, right? Unfortunately, there is a keyword in Python that messes with that, but it's forbidden. So the good news is I'm not going to teach it this semester. So let's see if PyCharm. Okay, it likes that spelling. Apparently, it didn't like the more French spelling or whatever. Anyway, so here's another way you can do this, right? So you're thinking, okay, I can definitely do this, but do I want to? And the answer is maybe not. So let's put if false around it. And then let's just do something else. So let's say for I in range 5, my function, like this. And so here, like if you say 1, 2, 3, 4, 5, here is us using our our function. Thanks for. I think we have two lectures going on. We have the nature of the omelet going on, and then we have the discussion of functions going on. So anyway, so here we have, I'm just running the function 5 times. Yeah, apparently the PyCharm's dictionary didn't have the other version. So, okay. Yeah. So, here's the thing. Okay. Okay, so you can use that. But, you might say, well, okay, but this is kinda pointless, right? And it's not kind of pointless. There are reasons to do this, but you might say to yourself, well, is there any way to communicate with a function, right? Because you might say to yourself, hey, I want to send some data into the function that will change, right, its behavior, right? So, and what I mean by that, the creator is Dutch, but I forget there's a lot of weird rules in Python. So okay, so I want to send some data into the function that'll change its behavior. So for instance, yeah, let's say that I want to make a draw grid function. So let's comment all this out, or not really comment, just if statement all of that out. And let's say that I want to make a draw grid function. And so, for instance, well, thank you for that opinion. I'm very happy to ignore that. So, because okay, so def draw grid, and so now what I'm going to do is I'm going to use something called a parameter. And so, I told you that you need this open and close parenthesis at the beginning of or at the end of your function declaration. And the important thing about this is that normally, you will want to pass something into the function. And so what I mean by pass, so the verb that we use is usually to pass, or maybe even to send some variable into the function, right? And so, oh, I shouldn't have typed the word pass there. So what I mean by that is that we have a variable name here. So watch me what I do. So I'll say size, right? So now size is a parameter of the draw grid function, okay? And so here what we're going to do is, let's say that we want to just draw a grid of that size. And I'll make the character equal to A, or X. Nah, asterisk. Okay, for I in range grid, size, for J in range size, print character with the end equals that, print the new line. Can you use the variables? Yes, but that is using global variables, which I'll talk about in a little bit. So it is technically possible, but not allowed. So you notice that you can declare new variables inside of a function. How do you spell declare? D-E-C-L-A-R. Just a transposition error. Okay. So here I've picked the character. Now you might say, well, why don't you send in 2 parameters? And I'm like, well, I haven't gotten there yet. So basically what I'm going to do here is say draw grid at 5, and then I'll print an empty line, right? And then I'll draw grid of size, say 12, and then I'll print an empty line and draw grid of size, say 7, and I guess we don't need this last print, right? So this is, we can put this in our like if name equals main block, right? Our main block of code. So basically here, let's run this and see what happens. Woo. So you notice here we've drawn 1 grid of size 5, and then here, unfortunately, it's big, so we've drawn 1 grid of size 5, and then we've drawn 1 grid of size 12, and then we've drawn another grid of size 7. And so you notice what this is doing for us, right? So this is like one of the benefits of a function. So yeah, let's actually just say it. One of the benefits of a function is that you don't have to repeat this code, right? You can just reuse the same code multiple times. And you notice this is not quite a loop, right? Because every time it goes through, I mean, you could make this into a loop. There's a number of things you could do, but this is, what we're doing here isn't exactly a loop. It's just that this function is being called once with an argument or parameter of 5. It's been called another time with a parameter of 12, and it's being called another time with a parameter of 7. And so basically what happens is, as soon as it gets called, whatever gets put into this first parameter goes into the size variable, okay? And then, so then you might ask a question, can I have multiple parameters? And the answer is yes. So you can have multiple parameters. And so the reason why you can, let's just say the character, and then let's take this out and put the character in here. And then here you see that PyCharm is yelling at me. It says you want to fill it, so let's fill the first one with asterisks, the second one with A's, and the third one with ampersands. Okay, so let's do it this way. And so you see that here we're drawing the first block, right? A block of size 5 by 5 I should say, with stars, a block of size 12 by 12 with A's, and a block of size 7 by 7 with asterisks. And so here's the thing. Variables, I shouldn't do that. Variables declared inside of the function, say for instance size and the char, are called local. And what that means is a local variable only exists as long as the function exists, and then it's erased, forgotten, whatever. Right? It's basically erased, forgotten, deleted, whatever you want to call it. Okay? And so, for instance, here, size is equal to 5 when we go through the loop for the function the first time, and character is equal to star. But as soon as we leave the function, so for instance, if I tried to print out size here or the character, what's going to happen is, let's see what happens. So it says name error. The size is not defined. And so you might ask yourself, what happened to that variable? The answer is this variable only exists inside of this function, okay? Once this function ends, so once it gets, so you notice how everything here is tabbed in. As soon as we get out of the function, so that means returning to the regular tab level, right? Here is the end of the function. Once we get to the end, there's, what should we say? Once we get to the end, a few things happen. One thing that happens is all the local variables die. Yeah, that's it. Just wants 2 blank lines between every function. That's what it wants. So, it's just a coding standard. So, here's the secret. Whatever you want to know about why something is yelling at you for style, for coding standards, the answer is there is this thing called PEP8. Here's PEP8. And so in PEP8, there's all this stuff. There's all these chapter headings. So if you look at, for instance, naming conventions, right, they go through all this stuff, and then they say, you know, class names, variable names should be, you know, snake case, functions and variable names should be lowercase with words separated by underscores, right? This is where I'm getting all this stuff. It's not completely made up. This is the like official Python PEP8 standard. And you might say, but wait, why do we have to follow the standard that the language gives? It's just, you know, no, there's no technical application. It's literally, and so you notice here, surround top-level functions with 2 blank lines. Method definitions are inside a class are surrounded by a single blank line. Is any of this written in stone? Not really, but it is written by the guy who made the language, so people tend to follow it. Okay. Okay, yeah, that's a good question. How did your function know to choose an item to print and not look at its numerical value? So remember that every character has a numerical value. The numerical value of a character can be retrieved by doing ORD of the character. On the other hand, if you just print the character, that's just going to print the character, right? So nothing is going to convert this into its numerical value unless you explicitly do it. Okay, so you're talking about the range, but I'm not sure. Okay. Okay, cool, because I didn't... You lost me for a second. I didn't completely understand. So, okay. Does Python use ASCII? The answer is yes. Python... Basically, it's not so much that Python uses ASCII, it's that computers use ASCII, and Python just accepts that fact. Basically, most... I mean, I guess you could say something about Unicode, right? But almost every programming language is going to start off by using ASCII. I think Java might use Unicode by default now. But the point is that even if you're using Unicode, the first byte of the Unicode is still ASCII characters. So there we go. Okay. Yeah, I think that's Python uses computers. That's... Yeah. Okay. All right. So I know that we already have a way to compute, you know, square roots, and well, let's just make let's do a simple function. Let's do another function where we do something else. So let me put this in my don't run it block. So let's define a new function. Compute poly, right? And so the polynomial that we're going to compute for absolutely no reason is x squared minus x minus 1. And so the parameter is going to be x. Just for the sake of completeness, when you make 3 little double quote marks, it will actually do this for you. And so here, this is the standard function documentation. So I encourage you to use this or something like this to document your functions. You don't have to use exactly this standard. I really don't care, but it's always nice if you document your functions. Basically just put some bit of code that describes how the function works, right? You would say computes x squared minus x minus 1, right? And so then here parameter x should be a float or int, value to be computed, and then we're going to return and of course you don't know where return is, the value of the computation, right? And now this is all kind of stupid. You don't have to document things like exactly this literally, but I'm going to do it because this is our first example. So here I'm going to use a keyword, and the keyword is going to be return. And here, remember, I can't do x squared, so I know that I'm intermixing notation, but here I'm going to do x squared minus x minus 1. And then the question is, what the heck is this doing, right? So what if we print, say, compute poly of, say, 5, right? So we look at it and we say, okay, x squared, so 5 squared is 25, minus 5, 20, minus 1, so 19, right? So what's going to happen here is that this thing is going to get computed. You can even make a variable like computed value, but you don't have to. So I'm just going to do it this way. So the value should be 19. So what happens when we do this? What happens when we do this is 19 gets printed out. So we notice that this function, right, when it came back from this process, right, what happened is that it had a value associated with it, right? So basically what ends up happening is that this function, we stick in a value of 5, and somehow whenever this function returns to this print statement, it replaces itself with the result, whatever's in return. So whatever's in return replaces the function call and allows you to save some data that comes back from the function itself. So sometimes you want to know something, right? And so here, if we do, say, while s is not equal to quit, and then you do something like this, and then we say s equals input, enter number or quit, and then we do some priming of the input, and then we do something like this. So we say, okay, enter number or quit, so enter 5. 19, we'll enter 17, which I guess I'd have to think about, right? It's like 289 minus 17 minus 1, so what is it? Something like 271 or something. And then maybe 123 for no reason, and then like 1.6. Ooh, wonderful. I forgot. I'm an idiot. Okay, float. There we go. 1.6. There we go. 1.618. Cool. So notice that Python uses kind of like the engineering version of scientific notation when it prints out this stuff. This is really like negative 7.6 times 10 to the minus 5, right? So when you get this e minus 5 business, that's what it means. So this is a number very close to 0. Okay. So basically here, what actually is happening here, right, is that when this function computes this value, and then you see the return keyword, it's going to send that value back to this print statement because the function is computed inside of the print statement. Now, there's other things that you can do, right? you can save these returned values into variables. So if you save a return value into a variable, so let's define a new function. Let's put this code up in here, just for the sake of keeping it out of the way. So let's define a new function, right? Get name, and we say print, or I guess I should say input. What is your first name? And then we can input what is your last name. And then what we can do here is, so last name equals this, first equals this. And then what we can do is we can return, say, a list of first name, last name, like this. And so let's get name, right? And then just print it out. So my name is Eric Calvin. And what you see here is that it just sticks it into a list and it returns it. But the point is that after it returns it and after you print it, that data is lost forever, right? The reason why that data is lost is we never saved it. Remember that any variable that exists inside of this function dies after the return statement or after the end of the function. So no more variables after the return statement. Right? So basically these values get preserved, but the actual variable names go away. So so the problem is that this list that we've just created will actually just vanish, right? Because once we print it, and that sometimes that's fine. Sometimes that's all you want, but sometimes you want to save it. So so let's just type in, like, make it, username equals this, and then we can print out username like this. So Donald Duck. And so here what we see is that we actually have the username inside this variable, and then we print it out. So once we save it to the username variable, we can use the returned value over and over again. So we didn't lose it. So that's kind of the point of the return statement. The return statement, what it does is it allows you to get a value back from the function. Because remember that because everything in here is what's called in local scope, because first name, last name are local scope, what local scope means is that as soon as their scope dies, and their scope is the lifetime of the function, right, as soon as their scope dies, they go away too. So that's kind of the idea here. Okay. So as you can see, functions are extraordinarily useful, right? Because what they allow you to do is kind of keep code away from other code. So it allows you to do this kind of operation and then return a value to the rest of your program without messing up the rest of your program with all these other variables, and it keeps this functionality separate, right? Okay. So if you notice, there's a bunch of functions that we've already been calling. So for instance, like things like if you have a string and you do .lower on that string, right? Definitely a function. What else is a function? Strip, split, join, right? Those are all functions. They're technically something called class methods, but we'll get to that when we talk about classes. Methods are just functions that belong to a certain class. But the point is that, we've already been using a bunch of different functions already. And the reason why we use them is because Python actually provides a lot of functions for us to use. So, yep. Okay. Yeah, I mean, so that's the thing, is that most of the stuff you do in the real world why do the functions have parameters at the beginning? Well, the answer is because in order to take input, you need to have a parameter. So functions. So for instance, if I have let's say def square root, right, of x, and now I'm going to compute the square root using, I don't know, I guess using that while previous, or right, current minus previous is less than error, and so we'll say current is equal to, say, I don't know, -1, and we'll have previous equals x, I get, who knows, and then we say I think we should flip them like that. Previous minus x divided by previous. I think that's the sequence. And then what we can do is return current. Float object is not callable. Well, I'm not trying to call a float object. Oh, multiplication. Okay. So, again, that's because they are methods. But anyway, let's not get into that. I mean, let's just pretend that what's actually happening, is actually happening in Python, for instance, is when you call string.lower, like, what's actually happening, yeah, of course it can be, but my point is that, yeah, of course. But I don't want to do that. So I wanted to have some more code in there. So basically, lower is like a function like this, where the first thing is like the string at the beginning, right? And then anything else. So that's kind of how it works. Actually, when you feed something in Python, it actually shifts this first thing into the argument. It does a little bit of moving stuff around for you. Okay, and so so the answer is yes, you can just return x to the 0.5, definitely. But this is if you can't, pretend you can't do that, right? Okay, so also this one computes with a certain error, whereas the square root goes to basically the limit of the float. So anyway, yeah, so what if we do, for instance, like, square root, say, of 5, right, and we print that out. Did I put a default argument in there? I shouldn't have done that. Let's not put a default argument in there. So let's print out the square root of 5 and see what happens. I don't know if it's going to work because it's possible I screwed something up, but whatever. So let's just run it and see what happens. So the square root of is just 5. Okay. Well, the absolute value of the current minus previous is less than error. Previous equals current. Interesting. What have I screwed up here? So, while this is... Oh, because it's while it's bigger than error. Yep. I just have the condition backwards. So, let's have 5. And then, do we have an infinite loop? Looks like we do. maybe it's plus. There we go. So now we can check to see how close our function was. And I think it should be close to within 3 decimal places. So you see it agrees here, it agrees there. Actually, it agrees all the way until the very last decimal place, so it's actually pretty accurate. So let's get the square root of like 17, right? 17. Square root of, say, 23, right? Something like that. So here's a bunch of different square roots. You see that for the square root of 5, it was really accurate. For the square root of, so it's accurate until the 7 for the square root of 17. Not that it really matters, right? Oops, there we go. It's accurate until here, and then it starts going off the rails. And then this one is accurate until about here, and then it starts going off the rails. But if you need a quick approximation, so I imagine that this runs much faster than the square root function does, just because square roots are kind of difficult to compute, actually. So anyway, so basically here, you can adjust the kind of error that you want to see. So for instance, let's say that you only care to error within, say, 0.1, and let's see what happens if we do this. Then we see that here it only got us 3 decimal digits, or I guess actually 4 decimal digits of accuracy before it starts going off the rails. So we can change both the error and we can change the square root, the thing we're taking the square root of. And so basically, whenever we feed these arguments into here, it'll run this bit of code and it'll return whatever it thinks the square root is. And so this brings up a good point, right? A lot of functions, right, you don't necessarily have to understand exactly what is going on in someone else's function. So do you know exactly what .lower is doing? The answer is not really. Do you know exactly what strip is doing? Well, you kind of do, but you know what the function does. But do you know exactly how their code works? And the answer is no. So you don't have to worry about the specifics of their implementation if you understand how the function works and if their code doesn't have bugs. Obviously, if their code has bugs, then you or they or somebody else has to get back in there and actually fix it. But if their code actually works correctly, right, if it just works and works and works, then the answer is, then you don't have to actually understand all the things that are going on inside of that function. You just have to basically, in general, you have to read the documentation and you kind of just trust it. So x is going to be the value we take the square root of. Error is the maximum possible error between 2 estimates, and return is our estimated square root, right? And so as long as you know those 3 things, and as long as you believe that this function works, you don't actually have to worry too much about exactly what this code is doing. It might be something you just don't completely understand. It might be something that is beyond where you currently are. It might be something that uses things that you've never seen before. There's all kinds of weird stuff in Python. So the answer is, like, a lot of times you don't have to worry exactly about, how things are working. And that's a good thing, right? It's a good thing that you don't exactly have to understand all the functionality of every function that you call. The lower function, so let's actually write the .lower function. So let's write it. So for instance, I was going to do this. This is the next example anyway, and it's good you asked the question. So yes, let's write our own version of .lower. So it's not going to work exactly the same way. Our version of .lower is going to take in the string, right? All right, so that's how it works. And then what I'm going to do is I'm going to say for character in the string, and then we'll have new string equals empty string. And then we'll say if character, let's just say A is less than or equal to C is less than or equal to Z, then what we can do is some magic, right? So here's the magic. What we're going to do, else what we're going to do is just do new string plus equals C. So we're just going to add on the character if this isn't true. But if it's uppercase, what we're going to do is we are going to take the value of that character and we're going to subtract off 32. And then we're going to use CHR to get back to character. So CHR takes a number and spits out a character. ORD takes a character and spits out a number, really the ASCII value. And as it turns out, upper and lower case are different by 32. So actually, oh, I'm sorry, we have to add 32. So what we're going to do is we're going to do this. And so you might say, well, what the heck is that? Well, let's watch it. So let's do an if false here so that we don't have any more square roots going on. And then let's just have a little while loop, while s is not equal to quit. And then we'll say s equals input, enter string to be lowered. And so in this case, we're not going to use the regular dot lower, right? We're not going to do s dot lower, because that will call the function that's actually part of the string class. What we want to call is our own function lower, so we're going to call lower on s, right? So we're going to print it out like that. And then what we're going to do is we are going to do this again. So let's see what happens. Enter the string to be lowered. All caps is like yelling. Let's see if this works. Ready, set. Ha, none. Okay, so did I not return? No, I didn't return. There we go. So you see here that if you don't return the value, that's a good point. If you don't return the value, Python returns the special none object for you. Okay? So be careful of that. If you ever set something, if you ever get an error that says like none type, some kind of none type error, then probably you might be returning none. So let's try this again. All caps is great. It's the best. There we go. So you see all caps is great, it's the best, and then what we see is maybe so, you can do something like this and say, hello everybody, this is really dumb. And, but the point is that you see all this garbage and what's happening, right? So when we hit enter here, what happens? What happens is this thing gets fed into our function, right? It's getting fed into here. It's going through each character in the string. And then I'm using the little comparison operator. So I can actually say if A is less than or equal to C is less than or equal to Z. So if it's an uppercase character, we do this magical operation, right? What we do is we add 32 onto its ASCII value. And adding 32 onto its ASCII value converts it from uppercase to lowercase. And so that's just, it's an interesting fact. If you want, you can always memorize that uppercase starts at 65 and lowercase starts at 97. It's always good to have those things in your head, just as a programmer. But I'm never gonna test you on that. I'm just saying that it's good to know those facts, because occasionally, if you ever actually see some hex dumps or whatever, and you see the value of 65 come out, or the value 97 or whatever, and it's a character, you can tell what character it is by how far it is away from 65 or 97. So then there's other things like new line character and carriage return and all that stuff. But yeah, anyway, so each one has its own value. So, okay. Yeah, I mean, it's I would say that a lot of people probably don't know the ASCII values, but if you are if you really feel like it's, what would something like that spit out for numbers? Basically the thing is that, like, there's always times when... Yeah, I mean, it's not, like, it's not as essential anymore. It used to be something that you saw a huge amount of just hex dumps and all kinds of random stuff, and you had to kind of know a little bit about ASCII to convert from the numbers back to the characters. Nowadays, most things, especially in Python, are much easier, so you don't need any of that. So let's see what it does on all of these characters. Right? Hopefully it does nothing to them. So it does nothing until it sees the uppercase, and then it just converts it down to lowercase. Right? So this is basically all... This is what .lower is doing, except now we have written it. So that's it. Okay. Let's see, what other kinds of examples should we do? Let's write my split, right? Which takes a string and splits it up like split does. So it splits it up. So we're not going to make something as advanced as Python's split function. We're just going to split by white space. The other, can you call one function and another function? Absolutely. Absolutely, you can. So, for instance, here you can call, like, lower a string. Fine. You can call square root on 5 with 0.1, right? You can do all that kind of stuff. Okay. Huh. Well, yeah, so they don't even... I guess they technically... Yeah, maybe I'll say that and say don't do it. So Python, for good and... Well, for like 2 or 3 good reasons and 100 bad reasons, I think that's really the way to say it. For there's like 2 good reasons and then like 100 bad reasons. You can declare, but don't ever in this class declare a function inside of a function. If you think that you need to declare a function inside of a function to make your code work, then I promise you that is not what you need to do. You don't need to do this. There are like 5 examples in all of Python where you have to do this. And we don't teach any of them in this class. They are very, 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 very strange examples why this feature exists. So you can declare like a new function in here. So you can declare like my random thing in here, and then my random thing can, you know, print out some other stuff. You know, it can even take arguments. So the point is, like, if you ever see this, the answer is no, right? Because this is a local function that only exists inside of this bigger function. And so you can't call this local function from outside. So if you ever need this code anywhere else in your code, you'll have to copy or cut paste it anyway outside. And so basically, don't do this, okay? Definitely don't do that. I feel like it's good to take the few minutes because I know people eventually find it online, or people look stuff up and they end up seeing, hey, I can create a function in a function. So this is me saying, when you look around online and you find that this is a possibility, remember that you're not supposed to do it. I mean, once you leave this class, you're free to do whatever you want. The only thing is that inside of this class, you are not free to do exactly whatever you want. You have to kind of follow the standard. So, okay, the other thing I should discuss is what is this pass keyword? And so I think I've used it a few times in the past with like for loops and while loops and stuff like that. So pass is a no op, okay? And so the reason why I use pass is because if you notice, if I don't use pass, then what I'm going to have here is so if I try to run this code, for instance, if I try to rerun this, okay, it worked. Oh, it worked because there's this. If I move this out, though, what you notice, that was too tricky. So, because remember that this is both a comment and a string. So, because this is both a comment and a string, it actually satisfies the requirement that every function, every loop, everything has to have one line of code inside it, and it doesn't count comments. So this thing, because it's a string, actually counts as like the line of code for Python. So anyway, but if you just declare a function, blah function, right, and you don't put anything in it, then you notice that there's this little red underline here, and if we try to run this code, it's going to say indentation error. And the reason why it says that is because there's nothing here, right? This function is expecting something here, right, at this tab level. And the problem is it's not getting it. So because it's not getting it, and let's say that you want to create the function, but you want to code it up later, right? Or you want to keep, you basically want to be able to have something at that tab level. You don't want to put a garbage string in there. You just want to have something at that tab level that'll just make Python happy. You can put pass in. But remember, pass does nothing, right? Okay? So pass does absolutely nothing, all right? The only reason why it exists is to be a placeholder, okay? So, I mean, you'll see in more advanced Python code, sometimes you'll see some passes in actual code, but for our purposes, it's even weirder than null. So null is just like a no object, but pass is is like a no line, right? It's a line of code that says, hello, I am here to maintain the correct tab level, to just be here, but I don't actually do anything, right? When Python sees the pass, it will just move to the next line, or in this case, it'll exit the function because there's no more function after that. But the point is that, yeah, that's the purpose for pass. And so I do use pass in this class a lot because I think it's good as a placeholder. You know, so there we go. No, so if you want to return multiple values from a, let's say we want to return multiple values. So here's how to do it. You return a list, okay? So say we have a value a equals 1, b equals 2, c equals 3, right? What we can do is we can return a list of a, b, c, like that. And that is how we do this, okay? So this is basically how to, so this is not returning multiple values, right? This is just declaring some random variables, but this is returning multiple values. So you stick it all in a list. Yeah, okay, well, cool. Then I totally, oh, I understand. Yes, you also said index it, which would be correct for a list. So, yeah. Yeah, so I guess that brings up another point that isn't exactly your question, but since I've answered your question, we should talk about it. So, for instance, let's say that we have def, actually, let's use the square root function again, okay? So what if we do something like this? Well, like, what if, you say, well, I know we can't take square roots of negative values. So if I say, if x is less than 0, then say we'll print, you cannot take the square root, square root of a negative. Now, of course, you might argue with me, but I don't care. And then let's say that we return -1, right? As like an error code here. Now, again, you might say, but Eric, you'll just get an imaginary number. But as it turns out, this algorithm here cannot generate those imaginary numbers, so there we are. Okay, so what happens if we try to take the square root of, say, -5 with an accuracy of 0.2? And if you look here, the return statement is in this if statement right here. Oh, can you? I didn't know that, right? But Eric, so the point here is that if x is less than 0, excuse me, it's going to print, you cannot take the square root of a negative, and then it's going to return. Now, you might say, maybe you should do an else statement here, but you don't actually have to, because after this line, if this line executes, we are out of this function, right? No code will execute after it, okay? So the return, even if you have multiple, so there's returning multiple values, which is this thing here. And then there's multiple return statements in a function. And whichever return statement gets hit first by your code will execute. And then the function just ends, right? So for instance here, let's see what happens if we do this, right? So we're going to print out a bunch of square roots. And then we're going to try to, let's print out the square root of this. And let's see what happens. So here it says you cannot take the square root of a negative. And so remember, that's actually getting printed inside of the square root function, and then it's returning a -1 to us. So basically we know that if we get a negative value for the square root, this is always returning the positive, well, it should always return the positive square root to us. So if it's always returning the positive square root to us, then basically what's going to happen is that, we know that -1 is a value that this function cannot return unless it's in the error state, right? So that's the good news for us, is that we know that -1 is not just going to randomly pop out, of that function unless it's a problem. So, okay. So that's basically, oh, wow. As it turns out, that's all for today. So we'll talk more about all of this stuff, and we'll do more examples of functions next time. So basically the point is here that functions are a way, it's like the first part of what we call abstraction, right? It's not as abstract as classes. So abstraction in terms of classes, no, not yet. But it is abstraction because you can hide functionality from another programmer, right? And all they need to understand is the input and the output of the function, right? Like, you didn't know how lower worked until today, but it didn't matter because you knew what the input of the function had to be. You knew you had to stick in a string and a dot lower, and you knew what the output of the function had to be, right? And so you could use that function without knowing exactly what that function is doing. And even if that function isn't doing the same thing as our lower function, we don't care. It's a different implementation, but it's producing the same result. So that's the whole point of all of this, okay? That's the idea. All right, I think that's good for today. I mean, I think we've done it. I think we've talked about functions. I think we know what parameters are. I'll talk a bit more about global and local scope next time. And I think that is it. So let me upload this to the GitHub. Commit. Function lecture. Commit. And then push it. And I think that's one of the main reasons, the last thing I'll say is that's one of the main reasons why I do the square root example, is exactly to prove to you that even if you don't understand the functionality inside or the coding of the function itself, right? Maybe you don't understand how this equation works. The point is that you know that the function is called square root, and you know how it works on the outside, and that's what matters. If you have to write the function, you have to understand it on the inside. But if you don't write the function, then all you have to do is just understand what goes in and what comes out. All right, and that is it for today. So I will let you all go and that kind of stuff. So let me find OBS and outro.